Hello, everybody. Welcome back to Dispatch. We've got a friendly face returning guest and also the star of our upcoming Analogic AI series.
Alex, great to be with you.
It's good to have you back. Not tan, but still great to have you back. I might get a tan myself. It's a gorgeous sunny day here in Chicago. We're approaching spring, and nothing. I want nothing more than to be out on a patio having a margarita. So I'm in the best mood, and even better since you're back, Mike. I want to get into it. There's been so much happening on the market right now with AI. I think it's quite literally. I feel like it's hit me like a bus, but I want to embrace it. I want to grab it by the horn here on Dispatch and fully dive in and kick off the series. A couple things I wanted to bring up, what I read this week is one, Meta may have trained its AI on 7 million pirated books, right? Like the kind of books we were illegally downloading in college. Like executives are saying that it's fair use of knowledge and information. Internet trolls are calling it theft, even though they're doing it themselves. And it's raining subpoenas, right? But this brings up a really big issue because it's not just about copyright, right? It's about trusting in our AI and our AI agents we're building out. Because can we really build the future of AI on a foundation of stolen docs? That's really shitty to think about. So that's one thing I wanted to bring to the table. The other thing was really interesting topic. I sent you the YouTube link on it. Did you listen to it? The Carl Schumann podcast.
I
It
want to, yes.
it's insane because that something really stuck with me. The we're A quote he said, we're entering an era of where like intelligent researchers, right? Threat intel researchers like yourselves, like Kevin Lowe, even these geniuses can't keep up with the information explosion that's happening. Like they're struggling to keep up with researchers, and we're seeing AI actually double and increase the performance of this information, right? Wrapping the curve, and so much so that we're getting left behind at the pace that we're evolving. So I'll drop in some of that content in the show notes. But I want to talk about some of the things we're building, right? Because Mike, you're not just talking about AI here, right? You're actively building it.
Yep, exactly. Not just on the beach, not getting tanned. Exactly, right? When I'm not doing that, not getting tanned on the beach, right? We're in the lab. We're trying to build out AI, right, for detection engineering as well as identifying threats in our customer logs.
Yeah, and you're leading and also contributing to our product, but also to the open source community, which community is really big and really important for us here in Dispatch. You're directly adding a bunch of LLMs and models to the Hugging Face community, and of course to us and shaping what's next. But I wanted to talk about what you're working on right now, but also a little bit of a tribute and ode to our last episode. If you haven't caught our last episode on UEBA, how traditional ML driven models and these static models of UEBA is falling short. It's not keeping up with the intensity and the volume of today's workloads. Are LLMs the hero in this story? Should we be taking the LLM approach to that? You're back. What are your thoughts on this?
This is a great question because believe it or not, I was in the UEBA space, right? Back in Semantic, we did data insights. It was a small product. It was an influential product. It was had to do with data governance, right? So that we had customers, part of the military, large organizations, and really what they were curious about was, did anyone have their fingers in the cookie jar? That was the issue, is that they had very, sensitive data. We use social network analysis. I mean, do you remember that? This is all the rage, like 10 years ago, right?
Was.
SNA stuff, right? Interesting movie, but SNA, right, was a very effective technique at that time. And the question is, have these techniques aged well compared to like the new world that we live in, which is all about AI, AIO, all your LLMs, all this stuff, right? You hear it all day long. So I would say that, like, like any team, right? I look at my beloved Boston Celtics, right? And certainly you have some star power there, right? You have, your Jason Tatum's, Jaylen Brown, right? Like you have these exceptional people that do things very well, but you also have like a plurality of talents, right? Peyton Pritchard, sixth man of the year award right there. It's one of those things that it's absolutely critical that, attacks can manifest in so many different ways, right? And sometimes maybe the only thing you see is, wow, there seems to be gigabytes of traffic making its way to Malaysia, right? And that type of detection, you're probably not going to use an LLM for that, right? That's going to be a simple statistical model. You say, like, look, for any unusual ASN, how much external traffic do I expect, right? So you don't need an LM to do that for you. Again, you just do mean, standard deviation, maybe 3, maybe 5. You decide, right? Classic UABA stuff. That's good. That works really well for that use case. There's no reason to abandon that, right? Maybe the social network stuff, it can still be used, it still be very interesting. Graphs can be run very effectively, computationally effective. But then on the other hand, like let's say, you and I are in the SOC, right? And we were looking at our EDR logs. And wow, there's like millions of EDR logs here. And maybe we play some tricks, right? We say, oh, this process looks pretty common. I've seen it on many hosts. I can ignore that. But like for these traditional UEBA type of techniques, right? It would be hard to say, like, how do I do that for a string field like a process or a URL or a domain or something like that. So this is where LLMs can be super interesting, right? One thing you could do, I mean, you can just give it to O3 or Gemini and say, hey, does this look funny? Does this look suspicious, right? And it will say something. It'll cost you a lot, but it will say something. It will tell you something about it, right? The other thing you could do is potentially, have more tactical LLM, right? That basically you say, look, I take one of these open source models and I say, hey, maybe I tune it. Maybe I say, hey, I train this model to identify patterns that are suspicious or malicious, and then be able to, give that back as a score. And I can use that score to say, hey, if it's above a certain threshold, I might want to take a look at it. Because again, I have millions of these EDR logs every day. Where should I be spending my time? Which processes, which outbound domains, URLs, where do I need to be looking? So yeah, I think like I wouldn't necessarily, UEBA, is great for very specific type tasks, and I think it works well, and you should still absolutely be using those techniques. But like for my day to day, being able to say, look, we have a ton of text data flowing through our customer environments that we see for the detections that we write to try to make that a manageable amount of things to look through. You still have a lot of things to look through, and that's where LMs can do a great job of classifying, ranking, and summarizing that information.
So we're getting to a point where we should probably reassess what we use UEBA smaller types of models for and just carefully relook at that, right? So I guess are you building anything that may do this in a better way? Anything that we can expect?
Well, yeah, I would say that like we did release a few things, right? Our discussion today with the URL classifier, and my kids love when I show up on this program, right? Because they're like, "Hey, Dad's on Spotify,"
He's
right?
on.
So
Yeah.
exactly. That's the only thing that's impressed them in the last 5 years that I've done. But no, basically, yeah, like I think that there's other kinds of models that we're looking into. Like, for example, your audience might be familiar with what's called named entity recognition, where you teach an LLM or deep neural network, hey, can you extract this kind of thing? Maybe a name, domain, URL. We're looking in ways that, those are the kind of models that we build out to kind of extract things. We also you may be familiar with process embeddings. So basically, you take some string, text, create it into a vector, so you can search it. You can do RAG. You can compare it to other things that you know. And we have a specialized model for process. So we got to see if we can try to release that to the open source community. But yeah, there's a lot of those kind of like really specific, targeted, bespoke models that we build out to do very specific things to help our detection content really shine. Like people can write great rules, but even those rules are going to have some amount of volume with, right? Just they're going to detect many things. So we have ways to tune them. We have ways to find those kind of like malicious or suspicious things in all of that text data that invariably you get in your SOC.
So URL classification is better suited for an LLM rather than I don't know, a risky behavior of a user.
Exactly. And again, like there are, good measures of user, risky behavior, maybe with SNA, like in very specific contexts, but also that requires having good like governance data, like, for example, like Alex, do you belong to what organization, right? Who do you typically work with, right? There's a lot of things that have to happen to make those UEBA models really shine. And they can
Mhm.
be done. I'm not saying they can't, right? It's just, it's a lot of work. But if it's something where most likely what's going to happen is, we have an adversary. I mean, what we've seen really recently with MSHDA is that basically we have these compromised hosts that are running these processes that are running MSHDA that are pulling things from the internet to run more malware on their systems, right? So in terms of just like yield and trying to figure out have you been, compromised, that kind of text analysis, which is well within the wheelhouse of LLMs, is probably the way to go in that direction. If you're looking for insider threat, yeah, there's definitely UEBA things that are very specific and well tuned for those. So yeah, I think that would be like you have to have all the players out there, right? It's like you have to have a good team of detections, and absolutely you need on your team some UEBA detections, really kind of target that insider case. But
Mhm.
definitely if we're talking about responding to, external intrusions like compromise and things like that, that's where being able to efficiently classify text in a very general way is where
Mhm.
LLMs really shine, I would say.
Yeah. Absolutely. Last thing I'll say on UEBA, because there was heated debate on it on LinkedIn. There was heated debate on whether, how in the past a lot of us come from the UEBA world, like yourself, right? Like Karthik. And now we're having a different approach on it. But I mean, it's okay to say that for that a period of time, UEBA, what was needed, right? The data sets were much more small and controlled in nature, and those type of things was what was appropriate, right? But that's not the case across hybrid, complex multi-cloud environments. And so now it's time to turn to this, explosion of agentic AI and AI use. And I'm really excited to see what you guys are coming out with all the time. I guess what has been the most exciting for me has been just the change. Like it's so surprising to see where we are at in just a months, 2 months worth of time, the explosion of AI agent adoption and everybody and their grandma's website having now AI agents in the mix. Like how true and realistic really is that? I I feel like probably barely 50%. We'll test it. Let's see what they have to say at RSA. But for us in particular, I'm seeing it come to life, and I'm so excited to showcase it and show you and show our listeners what we're building on to the product. So why don't you give us the grand tour of what we're building with your URL classifier?
Absolutely. Absolutely. Before we jump in, you said something really interesting. I was just thinking about, like, you mentioned the speed, right? Things are changing, right? So when I started my PhD, right, this is way long ago. So I'm just going to say 2009, right? Even though it started before that, right? We had language models, right? But they were like statistical, basically n-gram models. And now it's amazing because we have these reasoning agents. And it's really difficult because I think, like, the thing is that there's so much hype. You can play around with these things very easily. Sometimes they give you magnificent results. Sometimes
Yeah.
they're garbage, right? You never know, right? And it's difficult because particularly on that high end, right? That high end of LLMs, your Geminis, your O3s. I mean, those are like, I mean, compared to these Ngram models that I was using in 2009, they're like Bugattis, right? Like these are just amazing, very capable machine learning models that, kind of approach, general intelligence, right? Like they do sometimes come up with very smart, very intelligent things to say and, can solve problems effectively, right? But I think the thing is, like, when we're talking about, like, for your sock though, right? Like it's great that, like, hey, I want O3 to write me or Gemini to write me a poem or something like that. That's cool, right? Like write me a limerick, right? That's great. Like that's good for that model. It's very clever. It can do that pretty well, right? But like you can't really run those models at scale, right? Like it's just be impossible. We're talking about like being in the SOC, EDR. You got millions of processes to go through every day. Can you really afford, can you really scale up, right? Running O3 or even something of that size, right? Against all those models, right? I mean, like if I worked for Hurtado Enterprises, right, and I was your driver, right, what would you do? Would you give me the Bugatti because you're like, Mike, I need you to get those deliveries out real fast? Or would you say, here's the Sprinter van, right? You can put a lot of things in there. And oh, by the way, there's speed limits in this country, right? So you can't just be going like, 120, down resident streets, right? No, Sprinter van's the way to go. So what I like to think about is like what is the right model for the right task, right? And I think specifically there, for, a lot of your EDR data, it's going to be one of those things that, like, it's going to be very specific. It's going to be like, hey, I see a domain. What we talked about last time I was on detection dispatch is, does this look like a typo squat? Do I
Mm,
need do I need the Bugatti to figure that out? No, I don't need the O3 or the Gemini. Actually, what we found was that by training our own models that were much smaller based on, I mean, again, I feel like I'm dating myself, but burp style LLMs, right? Transformer architectures that were, kind of like the inception of like these later stage, architectures, right? And what was that? Was this like 2019, 2018? We're gonna have to go in the show notes and correct that if I'm wrong. But whatever, I mean, again, it's like half a decade, less than a decade ago, right? Those were the rage, right? Now we're in a whole different with these autoaggressive models. Like it's pretty crazy how quickly things have changed. But those type of models have a lot of capability and they can be run super efficiently on, very cheap hardware in the cloud, right? So why not take advantage of their innate capabilities to take text and provide you basically summary or extraction of entities or even classification. So let me just, pull up my screen right here and I'll show you our Hugging Face repository. But yeah, so I'm very excited because I think like really what I want, if you take anything away from this conversation that we're having, is that it's really good just to say like, look, there's a lot of hype, right? Everyone is talking about LLMs and how they're going to change the world. And, there's some truth there. I think like it's very possible it's excellent technology. But like you don't, I think the big thing is like what is right for your use case, right? And if you're in the SOC, right? And let's say, you are a detection engineer and you write detections, right? You write detections that go against web proxy, or maybe you extract URLs and domains from your EDR logs from process fields, right? How can we leverage LLMs in that case, right? And what you can do is use these models that we have here, like our typo squat model and our URL Guardian, our new model that we've released, to basically say, hey, can we find malicious URLs, right? And you get the advantages, you get the power of these LLMs, their ability to generalize and to do these ranking tasks, but you can run them performantly in your environment, right? You don't need to buy high-end or rent high-end GPUs to basically run these particular models. I mean, heck, you can run it on your own laptop. If you have Apple Silicon, there you go, even better, right? But all of these run very efficiently on cloud GPU instances and don't really require a lot of money and they scale pretty well. I mean, we use them actually internally. Like we have our own GPU-based deployments of these models that we run against all of our customers' detections that come through Anvil Logic. So yeah, so what I would say here, it's really what I like to call the power of and. But again, like let's say you have some content, right? You have web proxy detections, you have detections for endpoint, right? And you say, look, here's a URL. What do I want to know about it? So I want to show you this winner, Alex, right? So basically we found recently, and the best thing is I got to make sure I type this in and paste it without accidentally going to the website. But this is an actual malicious web URL that we found, right? So this
or the
is
dog love. It would
or
fool me. I'd go in there.
exactly, right? So this, okay, just quick tangent. We can have a quick tangent, right? We see a lot of this now, right? The sort of like, actually dating myself again. So one of the things when I joined up at Semantic back in the early 2010s, right, is we saw a lot of domain generation algorithms. So like these sort of randomized domains that would be generated and they would just look like garbage, right? Like and that's actually how I got into language models. So I was like, hey, if you had a language model, you could say, does this look funny, right? Does this look like a normal kind of domain or like English, text? And you say no, right? That's crazy. There's a lot of Q's and Z's. Doesn't make any sense to me, right? It seems like the criminal element, they're doing a better job of creating maybe like defensible, like
Mm,
randomized domains. Like again, like this, I mean, this wouldn't be a terrible domain, but I've seen some terrible ones recently, like glitchprovolone.com or something like that. Like, there's like crazy kind of like combinations where they're randomly sampling words from a dictionary and they just kind of mush them into the domain name. So yeah, this one's a lot better. But like clearly, like if this was me, right? Like this doesn't look like rayverify.html. Like when you go to any of the websites, yeah, right, you wouldn't go to this, right? If you saw it, right, if you clicked on the link and you saw it in the URL bar, you'd be like, this is kind of weird. So what this model will do is provide you a classification, right? And that classification will tell you like, hey, does this look unsafe or does it look safe? And it gives you a score. It's not a perfect model, right? What we've done is we've been able to kind of source data sets of malicious URLs from the internet. And what we try to do is we try to teach this LLM basically, here are the trends and sort of like normal and malicious URLs, and then provide basically a ranking score. So if we take this here, see, this is why I brought up Pritchard earlier, Mr. Peyton Pritchard. But again, if I give it sort of a normal kind of like domain like this one over here for ESPN, right, which is actually right down the street from me. I live in Connecticut here. But if we check the safety of this one, oh, actually, sorry, just kidding, it's apnews.com. But again, like this one is correctly classified as this being safe, or it doesn't have the hallmarks of what people are reporting as malicious URL. So again, mainly a lot of discussion, and this is a very simple model, but the reason why we release it is hopefully it's useful and you can use it with the power of and, right? You have your detection, you have your endpoint, detections for endpoint, for proxy. You get URLs, you can extract them manually, or maybe they're just parsed out by virtue of the event log that you're looking at. So why not just run this model and help you prioritize like the, hundreds, thousands, tens of thousands, millions of things that you might see every day. So that is what we have released. And this is something that, yep, you can go to our Hugging Face. You can request access to the model. Here it is. Got lots of fun information about it. You get to see what the full model architecture is. So basically, this is a Distilbert base case. So again, this is the very best of probably what 2019, 2020. I have to fact check myself on that. But again, this works well, super efficient to run using the transformers library. We give some examples of, I love this example right here. Good old secure login.xyz. Again,
Oh God.
this is what they do. Now you and I can see that and say, yeah, that's totally fake, right? Like, this is not a legitimate company, and particularly when you put the PayPal.com in front of it. But basically, like again, like this is the kind of things that again you can teach a model, and you don't have to get the O3 model to do this, right? Wouldn't really be able to fine tune the O3. Well, maybe I actually don't know which ones you can fine tune, but you don't need a 100 billion plus parameter model fine tuned to do this, right? You can have this model, which is way smaller, very easy to run, and does a fairly good job of this sort of binary classification task. So again, actually kind of like UEBA, like when I did UEBA, it was one of those things that we would have these sort of point detections. So it's always good that, look, it's hard to find perfect machine learning classifiers out there. So absolutely always couple the output of any machine learning model that you have, right, with at least one other interesting piece of information, right? So again, if you have some sort of detection for your proxy or endpoint logs, and then you run this in addition to it, and you find that it thinks a URL in it is suspicious, then absolutely, like that would be maybe worth someone's time to actually take a look at. Because at the end of the day, right, what is the most expensive asset that you have, right? Are your analysts in your SOC, right? So let's try to use their time efficiently. And that's how you can sort of couple, these systems, which are weakly predictive, like they do pretty well, they're fairly accurate, right? But couple that with good detections that you write, and hopefully this will really kind of help elevate the content that really needs to be triaged as soon as possible.
I love that. Can you go back to when it produced an output? I want to unpack something there. When it gave a classification, right? It gave a safe or an unsafe output here. Wanted to be crystal clear on this isn't, you pasting a URL and it cross matching against virus total, right? IP and this is not IOC matching here. Like this is making sense out of what patterns of bad URLs are, right? This is not just a hit on a malicious URL, right? This is pattern, deriving patterns, which is going to be a better strategy than just unknown versus unknown IOC.
Exactly, exactly. So let me show, like here, you could absolutely take that IOC approach, right? So these are, malicious URLs according to URL House, which is a good place if you need to source IOCs or, find these particular patterns. But I mean, the thing is, like, if we can do better, right? If we can start looking at these, and of course, I pick one that is not, you don't see a ton of entropy here. But look, I mean, like, honestly, like, would you ever see, like, this is a shell file, right? Then,
Yeah.
right? So, like, the model can generalize from there. It can say like, okay, right? Like generally speaking, if I go to apnews.com, anvillogic.com, I was gonna say facebook.com, Instagram, right? Not a lot of URLs when you click through those sites that are going to end with like .sh, right? So that's exactly the a great point that you brought up here is that it's generalizing that knowledge. So here, I mean, we're looking at these, you can eyeball them and say, yeah, obviously I see some patterns here. And ideally, if we do our job well, right, then we can build out these patterns. The model will learn to generalize and pick up things like, yeah, so if it ends in .sh, if it's a super short URL path in the URL, right? Those are the kind of things that hopefully it's picking up on and why we're able to detect what we can detect. Because if we go back to this one over here, the sort of ray.verify, I'm 100% certain, 99.999% certain that, yeah, we definitely didn't see this one in our training set. Like this is fairly new. And Kevin Zuck actually discovered this one. So yeah, so again, this is something where it's able to verify that, again, this kind of path, the way that it looks, the extension, some of the terms in the actual domain suggests that this is very similar to other patterns that we've seen in malicious URLs, and it's not relying on an IOC or substring match.
I love that. Now, how do I put this into an easy app for like my grandma to test all of her little phishing texts? They're getting better and better, I feel like. From one, I got one this week. I sent to Van Vliet. It came from an advisory, and if had it not been a WhatsApp link, I was like, I get these phishings all the time. If it wasn't the stupid WhatsApp link, I mean, it was easy to spot. But had it not been, I could have clicked it.
Exactly. Like that's the thing. Is like I'm looking right now on my phone, right? Because this is great. We're on detection dispatch. Let me take a quick look at my phone right here. No, we've gotten here in the Northeast. I don't know if we got anybody in the Northeast. Jeanette, I know you're in the Northeast. Did you get the easy pass? Yeah, she got the easy pass.
Oh, yes, I did. Every
Yes,
single day, literally.
yes, exactly, exactly. So these things are happening all the time. We got the easy pass in the Northeast, right? And they're just like these really goofy looking URLs. And I think like the thing is absolutely like, look, they're easy to spot, right? They sometimes are a little bit tricky, right? They try to be a little sophisticated in terms of using things that and taking advantage of your tired. So how can we get help grandma's sock, right? And I think the main thing here is with these types of models, there's so many different ways to take a Hugging Face model specifically and deploy it. So Hugging Face itself has ways that if you bring a model into your account, right, you can have it do, Hugging Face will actually serve it for you. So then you can actually use it via, Hugging Face, to just, do the inferences, get the classifications for you. The other thing is all the major cloud providers, because I mean, I'm curious, like, is grandma rocking AWS? Is she doing Azure? I'm curious, right? But either of those and GCP, I'm probably not GCP, but like, either of any of those, right, all have ways that if you take this particular model, you can host it using their AI ML serving inferences. And then all it is just basically a web request. And she would say, oh, got this URL. Don't want to bother Alex. She's doing a podcast with the crew, right? All she has to do is do a quick web request and she gets it back. So the hosting component is pretty easy. And they also make it fairly efficient. But look, you can do it your own. I mean, maybe, grandma's got, a nice laptop and she's got some Apple Silicon. So yeah, she could even probably potentially run it locally and it will run very quickly and not even use. So these kind of things, you could absolutely take this model, you can embed it, into, various applications that you have because it doesn't have a huge footprint, right? The whole model size is like 200 megabytes compressed. So it's not that big and it would be, something, but it would be easy enough to serve it using a third party provider like Hugging Face or what have you.
I'd be so interested to see how, with AI agents and AI agent orchestration, multi-agent communication, how this could be a part of an overarching workflow, right? To pass through a lot of this traffic through here before requests and things of that nature. But I really love overall what you said. Like this, and I can see clear as day that AI, unlike everybody else's approach to it, we don't really see it as a hype cycle, right? This is a logical evolution of decades worth of work, right? You're using whatever makes sense for certain applications, right? Classifiers, SVMs, like clusters for specific types of things, and understanding the different layers and really thinking about those strategically is going to be so important to it was a more balanced approach, right, to consume and embrace this AI uh, of it all. The other thing I've been seeing and reading about is the debate on what you're showing here, like just model tuning and getting better and better and more refined with this pattern, or prompt engineering. Like should we have our teams, your team, Mike, Scott Rogers and this is Scott Rogers of the world, should they invest more time in prompt engineering or more of their time in tuning these small models to perfection, right, for their application? Now that we know that there's better types and uses for certain things, what is better to do? How are you
What
thinking
is
about that?
This is tough. I think I have kind of like a rough rubric in my head, so I'm gonna try to spill it out. And again, like these are just my thoughts on what we found successful. And actually, I want to tie it also into agentic workflows. So you brought up a great point about how would I get this kind of URL guardian into my agentic workflows, right?
Mhm.
So when it comes to prompt engineering, I think probably the first question is like, how often are you going to run this LLM? If you're going to run it a lot, then you really have to ask yourself, like, is there a third-party provider? If I'm going to do the prompt engineering route and use something like OpenAI or Claude or Anthropic or something like that, does it make sense to run these models with this much input at scale? Do I have the budget for that, right? And do they even do a good job of giving me the output that I want, right? So it's always probably the first question is like, what can I realistically afford to do, right? But the second thing would be is there are great open source foundational models in addition to, what's available from third-party providers like Anthropic, OpenAI, and Google, right? So the prompt engineering is like almost sometimes can be like a cheat code, right? Because you can say, and actually I did this just in the last 24 hours, I wanted in my agent flow to pick out the appropriate event name for an AWS API action, right? And I wanted to look at EC2, IAM, and S3. And all I did was just dump it in the prompt. I said, hey, here's my question. Here are all the event names. Pick one or more of them that apply to my question here, right? And did a great job. So like that's a cheat code because I don't have to create some sort of multi-label classifier like what I had to do 10 years ago, right? Doing that 10 years ago would have been such a pain. It would have been like a 3-4 week adventure. And I don't know if I could do it well. Now I can just say, look, here's my prompt. Here's my question. You kind of know all about the internet. So let me just refresh you on what, are the values that are acceptable that you can output to me. And it does a great job. So that's where, I would always start with prompt engineering as the first go. Now, the second thing is with the prompt engineering, the question is, do you go like how much time do you spend, refining, crafting the prompt until you try like few shot? So few shot meaning like, hey, I'm going to try a couple of examples. And again, I should also confess, I'm not like the best prompt engineer in the world, but this is just my workflow, right? So basically I'd say, okay, I'm kind of hitting a wall with, just trying to update the prompt and like changing the text and changing the problem. So maybe I'll put some examples of inputs and outputs, and that also can help. So again, that could be the cheat code. You just, say, here's what I want you to do. Here's a couple of examples of what it should look like, and maybe it works out. And again, if it does, awesome, right? And if you can afford to run those models at the scale you need, even better. But fine tuning, right? Fine tuning is something we're doing for this. What we do for other models, for example, we have a model we run internally that if we have a tuning recommendation for our content and we generate a regex, it goes through this small language model to say, wait, does that make sense? Because let's say you had a tuning recommendation and all it was like star, right? Just match everything, right? That is something we don't want to submit as a regular expression tuning recommendation for someone's content because all of a sudden all their content will go to zero, right? So we want to avoid bad tuning regexes, right? To help people have more manageable volume of content. So there is where, yeah, like when it's really bespoke, it's very tactical, it's very strategic, and it may not be something that you do like is the models themselves would be trained on, right? Like basically cybersecurity. Then fine tuning gives you that extra pull, right? That's where I think you get a lot of benefit from it. And specifically here, right, you can mix and match, right? Again, we're just talking about the Celtics, right? There's a lot of different players with a lot of different talents, right? So for example, for simple things like, hey, simple things like URL classification, right? You don't really need to fine tune a 1 billion, 10 billion parameter model, right? You can take one of these existing kind of BERT style transformers, you tune it, you get outputs, great. And then you can put that into your agentic workflow, right? You can say like, here's some sort of security event, here's the log, here's the process, these are URLs that we extracted using our very small language model, right? From those extracted things, I got a URL that looks funny. Here's what URL Guardian thought about it. And then that actual reasoning piece can be done by a larger model. And you're really just kind of right sizing the LLM for the task that you have.
Yeah, I love that actually.
So,
So it seems like we're still in the phase where we're taking things in pieces, smaller for specialized needs. But do you think have you read the AI 2027 study? That's what's been. I just haven't stopped thinking about it. I think and what they say, I think in the future, it's not going to be small specialized models. It's going to be like all of our operations are going to be run by large, giant foundational models. Do you think that?
maybe someday, like in the large life, it's very interesting. I think that, I'm not
By
sure if I,
2027? By 2027?
that's pretty aggressive timeline. That's an aggressive time. I would say that likely or more realistically, you're going to get, as someone living in 2025, more pull of just using the right model for the right task, right? So
Yeah.
basically anything that's small, like, URL classification, or even just like, yeah, do a BERT style transformer. If you need to build out regexes, if you need to rank some findings that you have on an event, you can probably do a 1 to 10 billion parameter model, right? Like certainly, yeah, the capability might be there at some point for large models to do everything all at once, everything everywhere all at once, but probably not. Not by 2027. So that's my guess, but again, I don't work on the forefront of large language models, right? Like I work over here, whereas like, hey, we have very specific tactical bespoke problems
Mhm.
that our customers have, which is okay, I have
They're
tons of yeah,
tactical. Mhm.
waiting for 2027, right? I could be attacked right now. So I need to figure out like, what do I need to look at right now? So let's get them something practical, scalable, and cost effective.
Yeah. No, everybody needs a mic and on your side. Mike keeps us very grounded with this approach, and I really appreciate that because you know who is not very grounded with these approaches? AI influencers that have seem to have the loudest voice, right? But because you have, you know, detection, you're building detection engineering agents, you lead a team of data scientists and AI engineers, right? Not just you're not just theorizing about these things. What what I and based on what you said, like what is one thing that you wish that these AI influencers understood about the hard parts of actually operationalizing AI the right way, the grounding way, the sane way, right, for security and specifically for detection?
I think like, oh, there's so many places to start, right? I mean, it's cool being an influencer, right? You get to go on, people see your videos, they recognize you at airports, right? That's cool, right? Like, I'm sorry, I'm not going to be recognized at an airport. Even sometimes my kids walk by me at the airport. They're like, who's that guy, right? I'm like, oh, it's your dad, right? But no, right? It's just one of those things that what I would want them to know or maybe focus on is like, even here, what we found with the typo squatting is that we got, even if we tried a lot of prompt engineering to try to say like, hey, here's this thing, is this a typo squat of this domain, right? All sorts of theatrics didn't really work out. So one is being that if the models themselves are not grounded, they're not focused on that very specific task, right? Or not aligned to it, it's really going to be hard for that particular model to do well, right? And then the other thing, quite frankly, is like there's games you can play is if you, for example, have some sort of base model, right? Let's say you're using, what would be a good one? Which one do we like? So, yeah, we have different models that we appreciate, but like you can build fine tunings, but you can also use techniques like QLoRa effectively to build adapters. So you can efficiently fine tune many specific tasks for whatever your domain is. Here at cybersecurity, it could be sports analytics, right? It could be medicine, right? Whatever it is. But basically, like you don't even have to really necessarily fine tune the entire model, right? If you've created basically are able to fine tune adapters and use those, you can actually use them quite efficiently, right, to do these particular tasks. So I think what I find interesting about this space actually right now is like with GRPO and other kind of advances in training and fine tuning and quantization, right? You can really get a lot of intelligence and value from models between 500 million to 10 billion parameters. And that's probably where I want to spend most of my time thinking about it. But again, like it's cool, right? Like when you can, ask, OpenAI to, like write you a love letter so then you can pass it off, right? That's cool, right? That's cool. It does a great job, right? But, for us, like, in the SOC, that what you really want is to efficiently find the thing that may uncover a cyber attack in your environment.
Love that. Are you actually using ChatGPT to write love letters? I'm thinking about that as Mother's Day is coming up.
Mother's Day is coming up. That's a good question. Like maybe I'll try it now. No, I can't pull my.
No, you cannot do that. It has to
No,
come
no.
from the heart. Only use it for grammar, just adjusting the grammar.
Exactly. Grammar is really helpful. I mean, honestly, the one that the thing I use probably the most is like Google Translate, which is not technically an LLM, right? We're doing, language to language translation, but yeah, no. What do you use OpenAI for? I mean, really, for me, it's just actually, yeah, right. Like, I just ask it some random questions. I'm always curious, but I spend most of my time over here, trying to figure out like how do we take these things that are available and then use them efficiently.
And that's exactly what we need. You know what, I find that ChatGPT, I recently decommissioned my personal paid account because now our marketing team has now a Teams account and now we can expense it. But what I did migrate over to is Perplexity. I find out it's better for research, not content creation, but research. The sources are better, they're more accurate. So now I'm paying for that, and I have found it to be super, super useful.
I'm glad you mentioned Perplexity. I like Perplexity as well. And actually, probably what I use the LLMs most for is I coach a travel B team, and I have no idea what kind of formation I want to put them in, or like certain drills that I want to practice. I'm like, I'll let the AI tell me. Just summarize it, show me some good links, and then I'll go to the YouTube video or like TikTok. So that is what I use. That's probably what I'll use the LLMs for, and that's what they're great for. Like they do those things extremely well. Security stuff is more of a mixed bag.
And I think on that note, that's a pretty great spot to close our episode, Mike. I like how we started the episode. We're like, oh, we'll just cover 30 minutes. Now it's 45 minutes of LLM talks, which I'm so glad to have covered with you, to continue covering with you on the rest of our AI series. It's always great having you on to keep us sane and keep us grounded in this embrace into AI. So thank you so much for pulling back the curtain on what you guys are doing in our product, building onto our product with detection engineering use cases, but also for the community to try it out themselves, right? Using whatever model is best suited, as you said. So thank you so much to our listeners. If you want to see what this looks like in action, you can find the HuggingFace links in our show notes. And stay tuned for the rest of our Anvil-Logic AI series. We're going to have very, very shortly Scott Rogers on the lineup. So you could definitely come back for that. So thank you so much, Mike. Have a wonderful rest of your afternoon. I think I might just spend the rest of the afternoon outside. We'll catch you guys next time.